Hello, my name is Mr. J and welcome to Mentari World of Science. Join me today for a moment of growing, learning, and igniting your curiosity in the field of science. So in this activity, we will explore how different energy is transformed in our do-it-yourself spoon catapult. Did you know the earliest written records of catapults date back to the 3rd century BC? That's over 2,300 years ago. Catapults are actually used in many ancient wars to launch things over high castle walls. So, for our essential question, what are the energy transformations observed as we launch the projectiles in the different angles? For the materials, we are going to use some popsicle sticks, rubber bands, a spoon, and projectile power or loads like a crumpled paper or this pom-pom. We will build 2 prototypes of our catapult, one with 6 stacks and the other one with 12 stacks. So for our experiment procedure, take 6 popsicle sticks and line them up on top of each other. Next, take a rubber band and wrap it tightly on one end of the popsicle stick stack, just like this. The next thing is place 2 popsicle sticks between the first and the second popsicle stick stack, sliding it to the middle. Just like what we're doing right now. Next, take another rubber band and wrap it with one end of your popsicle stick stack. So your spoon catapult will look like this now. Now, the next thing that you're gonna do is grab your spoon and attach it to the handle or to one end of your popsicle stick. Then get another rubber band and tie it tightly. So this catapult that we just created has a 6 stack of popsicle stick. The next thing that you can do is to test it out. You can test out the catapult using the different kinds of projectiles or loads by pulling down the spoon. All you just need to do is to place your projectile there and let it fly. So that is for our 6 stacks. Then for our 12 stacks. So I have a question to ponder. Does the weight of what you are shooting make it go a longer or shorter distance? Try shooting different objects to see if the weight affects the distance. So aside from the pom-pom, you can actually use crumpled paper. Does the weight of this affect the distance it travels? We are on the concluding part of our experiment. Now, I will discuss the science behind the experiment. So, in this activity, the catapult created a lever propped up by a fulcrum or pivoting point. Your spoon catapult stores potential energy when you pull the spoon down. And when you let go of the spoon, the potential energy changes to kinetic and your object flies. So let's give it a try one more time. So this is our lever propped up by a pivot or a fulcrum. And as we pull the spoon down, it stores potential energy. And when you let go of the spoon, the potential energy changes into another energy, which is kinetic energy. So let's go further. Does the number of the sticks stacked in the middle matters? Try rebuilding your catapult with just 2 sticks in the middle. Does it work better or worse? Do it at home. So once again, this is Mr. J from Mentari World of Science, igniting your curiosity.